This video is bivariate statistics. Previously we looked at univariate statistics, which was where we had one variable. Now we're going to look at bivariate, which is when you have two variables. And when we have bivariate data, what we can often do is compare to see whether there is any correlation between the two variables. Correlation is a measure of the strength of the relationship or the association between two variables. We have different types of correlation. We have positive correlation, which is where the data is trending upwards. Negative, which is when it's trending downwards. And no correlation, where there doesn't appear to be a trend of upwards or downwards. Within correlation, we can then also describe it as strong, moderate, or weak. A strong correlation would be where it would look very much like a straight line, very close to a straight line. Moderate, you can still see there's an upward trend, but the data points are a bit more spread out. And weak, once again, you can kind of see there's an upward trend, but the data points are a lot more spread out. Correlations, we can also class them as linear or non-linear. Right now, we will only be looking at linear, but there is also non-linear correlations too. First example, Alexander researched the elevation above sea level and mean annual temperature of 12 cities around the world. The results are in the table. First of all, we're going to draw a scatter graph, and then we want to describe the relationship. So we're going to start with a scatter graph first, or a scatter plot, either or. I've got my axis already here, so now we're just going to plot the points. So the first elevation is 600 with a temperature of 15. So we go to 600, 15 and put a dot. And then we do that for each data point. The next one is 850 and 10, which would be there. So there is my scatter plot with all the points plotted. Now part B is describe the relationship between the elevation and mean temperature. So what we're going to do here is going to look at the data points, and we're going to first of all see, is it a positive or negative? And we will say that it is negative because we can see the points are trending downwards. And then we need to decide if we think it's strong, moderate, or weak. This comes down to personal opinion in these situations when we are just looking from a scatter plot. Personally, I would probably say it would be moderate. You could say maybe a little bit weaker, but there are ways to be able to know definitely where it sits, and that's what we're going to go on to now. We're now going to look at Pearson's product moment correlation coefficient. No, it's a very long name, but generally we'll just call it Pearson's or the R value. And it is a measure of the linear correlation between two variables x and y, and it will take a value between -1 and 1. So if it has a value of -1 or 1, it's basically a perfect correlation. All right, if it was a 1, it's a perfect positive, so it perfectly forms a straight line upwards. If it was -1, it is a perfect straight line going downwards. And then from there we can reduce our wording coming down towards 0. A 0 and R value would mean there's absolutely no correlation. The only difference between the positive and negatives is if it's an upward trend or a downward trend, and then the higher the value, the stronger the correlation. In the Year 10 textbook, these are the values that they give for the different types of correlation and what will be classed as weak, moderate, strong. Different textbooks and information will give slightly different values on these. In an exam situation, you would only be given a value where you would definitely know if it was a strong, moderate, weak, or no correlation. You would never be given a value that's on a borderline. Okay, example, we have the body mass index, BMI, and resting heart rate of a group of people were measured. There's our data. We're going to draw a scatter plot and then calculate the correlation coefficient for the data and interpret its value. With a scatter plot for this, I'm not going to draw it by hand. I'm actually just going to show you how you can do it on the calculator. And then in the calculator, we will then also calculate the R value, or the Pearson's product moment correlation coefficient value. First thing you're going to do is put your data into the spreadsheet, which I've already done here. When we want to draw a scatter plot of our data, we actually need to label our columns first. So we're going to head up to the top, and you see there I've got the box with the A highlighted, and in here we're going to label the column something. I would recommend using a word, just so if you start using variables like x and y, then it ends up getting sometimes confused in your calculator pages if you start doing things there. But this one was our BMI. So I'm going to actually just call that BMI. Then our second column was our beats per minute of our heart rate, of the heart rates. So I'm just going to call BPM. You can call them what you like, but we just need to have them named. From there, we want to create our scatter plot. So we're going to go back to the home page. And of all the icons at the bottom, you have this pink one here that looks like a bar chart. That is the graphic one. That's the one we are going to go to. So you're going to go to that. And it comes up with this. Now, this is not your scatter plot just yet. What we need to do to create the scatter plot is go to the bottom. You'll see here it says click to add variable. So we're going to click on there. And it says which variable is going to be your x-axis. This one is going to be our BMI. And then we go to the y-axis and it says click to add variable. And this one is our heart rate, the beats per minute. So we select that one. And now we have our scatter plot. So from here, we want to find our R value. Now we're going to go back to the spreadsheet to find the R value. So up the top here, I'm just going to go back to our spreadsheet. And to get the R value from here, we want to go to Menu, Statistics, Stat Calculations. This time though, we're going to be going to number 3, Linear Regression, mx plus b. Now I want you to always go to mx plus b, not the number 4, a plus bx. You'll find you'll end up making mistakes in exams if you go to the second one. So we're always going to go to mx plus b, number 3 for this. Like we've done previously, put in where our data is. Our first variable is in column A, our BMI. Our second variable is in column B. And everything else, just leave it as is. Results in column C, perfect, and OK. Now we have the statistics that have appeared, and you'll see here we have an R squared and an R value. Within maths, in the IB, we only ever look at the R value, so we want the single R, and here that is 0.85837. So that's our correlation value, so it's positive 0.85837. Now with that value then, we can make our conclusion on the correlation. So the R value was 0.85837, 3 significant figures, 0.858. Now we can go up to the table up here and we want to see where that falls. And we see it falls into this section here. So we would class it as a moderate positive correlation. Now with a value of 858, in some textbooks that would also be considered, that could be considered strong. It's kind of on a borderline. So just be careful there. But as I said, in an exam, you wouldn't be given a value like 0.858 as it is a borderline value where some people would say strong, some would say moderate, which means we would never ask you that. We would always ask you something where it is a definite strong, moderate, or weak. But with the tables we've got there, we would say that it is a moderate positive correlation. But if you said strong, I would be totally okay with that. And that is this video.